Welcome to The Explainer. Today, we're unpacking something absolutely wild, based on a fascinating piece of analysis by Y. Emre Toppin. We are literally going to look at how to read an AI's mind, right inside a browser tab. Just imagine watching a machine think about a historical monument, like Istanbul's Galata Tower, and actually seeing its thoughts form, layer by layer, before it even answers you. It's a trip. Let's get right into it.
Okay, let's dive right into our roadmap for today. We'll start by opening up the AI black box. Then we'll check out the 36-year argument. From there, we'll explore the tools we use to actually look inside an AI, walk through a really cool modern classroom experiment, and finally, we'll talk about why AI desperately needs social science.
All right, part one. The AI black box, a mind nobody wrote. To really get modern AI, you gotta wrap your head around this core mystery. Sure, engineers write the architecture, and they write the training recipe, but they absolutely do not author what the model actually ends up knowing. During training, billions of numbers just settle into values that no human ever chose or inspected. What comes out is grown, not built, and a grown thing doesn't come with a manual. This biological, almost anthropological metaphor is so spot on that Anthropic's interpretability team literally published a landmark paper titled On the Biology of a Large Language Model. We are essentially studying a newly discovered organism.
For the last 5 years or so, if you asked how a massive neural network made a specific decision, the honest answer was pretty much nobody knows. It was your classic black box. The engineers could see the data going in and the text coming out, but the internal decision-making process completely hidden in this massive, tangled web of numbers.
Moving on to part two, the 36-year argument. Can machines really have concepts?
To appreciate where we are today, we kind of have to look back at one of the absolute oldest brawls in cognitive science. Can a machine truly have a concept, or is it just faking it? Back in 1966, a program called ELIZA imitated a therapist using simple pattern matching rules. If you typed, "I am sad," it just replied, "Why are you sad?" It understood absolutely nothing about sadness. This led to a famous argument in 1988 by Fodor and Pilishin over in the symbolic camp. They argued that genuine thought requires symbols manipulated by hard rules. And for 36 years, this camp believed neural networks couldn't possess true concepts because they just tune mathematical weights instead of manipulating defined symbols. But fast forward to the 2020s, and modern networks showed us something completely wild. Concepts inside AI are actually directions in a high-dimensional space.
And this brilliantly illustrates a huge philosophical divide about meaning itself. On one side, we have the descriptivist, or symbolic view, which is basically like a dictionary. To possess the concept of a dog means holding the literal written definition of a four-legged barking animal. But then you have the causalist or connectivist view. This side argues that meaning isn't fixed by a definition at all. Instead, meaning is soaked up. It's absorbed from millions of contacts with the world. And if you squint, that is exactly how a neural network learns today. It doesn't have a written definition of a dog anywhere in its code. It just absorbs the meaning from millions of encounters in its training data.
Okay, part three. Tools to look inside. The observational side of interpretability. Now, the philosophical debate is super fun, but today, we don't just have to argue about it. We can actually open the model and look inside. We finally have the magnifying glasses needed to peer into these massive remote research GPUs right from our internet browsers. The first tool is called the Logit Lens, developed by Nasta Algebraist back in 2020. It's essentially a method that stops a model at every single layer of its processing and asks, hey, if you had to answer right now, what would you say? It lets us literally watch a thought form in real time. To see how this works, imagine feeding the AI the prompt, Miles Davis plays the, and you just leave it blank. If we use the Logit Lens to peek at the AI's early processing layers, we just see these vague guesses like thing. But as we move deeper into the middle layers, the model narrows its conceptual space to jazz and then horn. Finally, in the very deepest layers, the thought snaps into place and it lands precisely on trumpet. It's fascinating to watch a machine build an answer step by step like that.
Which builds right into our next tool, sparse autoencoders, or SAEs. See, individual artificial neurons are a total mess. Because an AI has way more concepts than it has neurons, one single neuron might fire for the concept of dogs, the concept of Tuesdays, and the concept of sarcasm, all at the exact same time. That jumble is called superposition. SAEs are these brilliant mathematical tools that untangle that mess into clean, nameable features. And here's the huge light bulb moment. Naming these untangled features is basically coding data, which requires exactly the kind of careful interpretive work social scientists do every single day.
Part 4. The Classroom Experiment.
Excavating cultural artifacts with a probe.
So, the author of our source, Emre Tapan, actually brought this exact technology into a classroom at SICS Istanbul. The students used a browser tool called the NDFI Workbench to test the model Llama 3.18b using closed fill-in-the-blank prompts. Let's look at this data neutrally. When prompted with, "The 2026 FIFA World Cup will be won by," the model's highest prediction was literally just the word at only 24.9% confidence. It doesn't know the future, so it hedges. But notice the second one. Even old New York was once new. That yields York at a massive 99.6% confidence. That near certainty tells us this isn't reasoning. It's a perfectly memorized song lyric. And for we should tax it outputs rich at 96.6%. These confidence percentages act like X-rays, revealing if the model is relying on grammar, memorization, or the underlying political sentiment of its training data.
Exploring further, the students tested another model, GPT-J, with prompts rooted in historical political theory. Feed it imperialism is the highest stage of, and the model reliably outputs capitalism, with 96.1% confidence. It's just completing Lenin's famous slogan right on cue. Prompted with capitalism is, it outputs dead at 27% confidence. Again, just neutrally observing these outputs, we see clear proof that these models are definitely not objective truth machines. They are highly compressed, highly responsive records of the specific human culture and texts they were trained on.
Now, what is really striking here is what happens when you compare models across cultures. A student asked almost the exact same question in 2 different languages to 2 different models. The English model stated a man's task is to live and a woman's task is to marry with over 90% confidence. But the Chinese model, QUN 2.5, completed the prompts with a man's task is to protect and a woman's task is to give birth. Nobody sat down and programmed these specific rules into the systems. By asking the same question across models, we are effectively interviewing 2 different cultural informants raised in totally different archives. We're uncovering 2 distinct patriarchies sitting right there in the mathematical weights. It's a cross-cultural contrast generated in 10 minutes that would take traditional researchers weeks to document.
Finally, Part 5, Why AI Needs Social Science, Reading the Meaning Behind the Weights.
All of this brings us to a pivotal question that Emre Tapan asked his classroom of computational social scientists during a live poll. Does AI need social science? Or does social science need AI? Because deciphering these cultural artifacts isn't just an engineering problem of tweaking code anymore. It's fast becoming a massive social science project.
And here's how the room voted. The consensus was pretty clear. 13 said both equally, and 8 said AI needs social science more. Only one single person said social science needs AI more. Why? Because sociologists have been mapping cultural meanings and concepts long before large language models even existed. Reading what an AI feature actually means requires what we call thick description. Watching an answer take shape across layers, that's process tracing. Knowing if a prompt actually measures what you think it measures is a classic problem of construct validity. AI critically needs the everyday toolkit of the social scientist to interpret what is really happening inside these networks.
So, the crucial point we have to take away is this. Large language models are no longer perfectly black boxes, but they aren't completely transparent white boxes either. They're translucent in patches. What we can see inside them using tools like the Logit Lens is very real, but it's local. It requires careful, rigorous interpretation that might not always scale effortlessly. We are dealing with a complex artifact of human culture here, not just a calculator.
And that leaves us with this incredibly powerful quote from the source. Social science would do fine without AI, but I find it hard to imagine AI becoming trustworthy without social scientists in the room. If we don't have experts who know how to measure bias, validate concepts, and interpret cultural data, we are never going to truly understand our own creations. Which leaves us with a final, pretty provocative question to think about. If our most advanced AI is ultimately just a translucent mirror reflecting the cultural sediment of its training data, what exactly are we feeding it? And whose reflection are we going to see looking back at us in the future?